For example 2, dividing by a monomial. Divide, write each polynomial in standard form. Okay, classify each polynomial by degree and term. Answers must be in standard form. Okay, so if I look here, 3 and 3, I'm just dividing 3 and 3. So 3 divided by 3 is 1. And then I have a 2 and a 1. Okay, well, when you have exponents on a fraction like this, you're going to subtract them. So 2 minus 1 gives me x to the first. And then I have negative 6 divided by 3. That's negative 2. And then x to the first minus x to the first is x to the 0. But x to the 0 is just a 1, and 2 times 1 would be that 2. So I'm not going to write it, okay? Now, for my final answer, I don't need these 1s right here. Okay, if it's in front of a variable or it's on an exponent, we don't need it. So my answer is x minus 2. My degree is just an invisible 1 there, so that's linear. And this particular answer has 2 terms. So 2 terms is a binomial. In part B, we're going to do the same thing. We're going to divide and then subtract. So divide 24 and 12, we get 2. Subtract 3 and 1, and we get x squared. 36 divided by 12, 3. And 2 minus 1 is 1. Don't forget your x. Negative 48 divided by 12 is negative 4. 1 minus 1 is 0. We don't write that at all. So then I go through and rewrite my answer. Again, we don't need the little 1 on the x. By degree, we would say a 2 is a quadratic. And we have 3 terms, which is a trinomial. In letter C, we would take this monomial and you put it underneath the big polynomial to show division. And now we don't need this part. So again, divide, subtract exponents. So 9 divided by 3 is 3, and 3 minus 2 is x to the first. Negative 6 divided by 3 is 2, but 2 minus 2 is 0, so we do not write it. 15 divided by 3 is 5, and 1 minus 2 is a negative 1. But in class, first semester, we talked about exponent rules, and we know that a negative exponent cannot exist. And so for this last term only, you put the whole entire term over 1, and then you're just going to move the x to the very bottom of that fraction. So my final answer would look like 3x minus 2 plus, keep the 5, and move the x to the bottom, making it a positive 1. But again, we don't need to write that 1. It's not really necessary. So by degree, our highest exponent is a 1 here, which is linear. And we have 1, 2, 3 terms, which then would be a trinomial. For letter D, I move the 9x to the third underneath the polynomial. And I will continue with the same routine. So I'm going to divide. 18 and 9 give me 2. Subtract my 5 and my 3, which also gives me 2. And then 27 divided by 9 gives me 3. 3 minus 3 is 0, so we do not write it. And then negative 18 divided by 9 is negative 2. But 1 minus 3 gives me a negative 2. So when I rewrite this, I need to rewrite it with a positive exponent. So I would say minus 2 over, bring this to the bottom, and have x squared. So my highest degree is a 2, which is a quadratic. And I have 3 terms, and 3 terms is called a trinomial. Okay. In letter E, same idea. You're going to divide. So 16 divided by 4 is 4. The x has a 1, and so does this x. So 1 minus 1 is 0, so I do not write the x. For y, I say 3 minus 1, and that's y squared. Then I have 4 divided by 4 is 1. 1 minus 1 is 0. Don't write the x. 2 minus 1 is y to the first. Negative 8 divided by 4 is negative 2. And then for the x's, 1 minus 1 is 0. Don't write it. For y, 1 minus 1 is 0. Don't write it. So when I rewrite my answer, I want to make sure that I don't have unnecessary ones. My highest exponent is a 2, which is called a quadratic. And I have 3 terms, which is a trinomial. In F, divide and write in standard form. We are not labeling. So again, divide, subtract, subtract. So we'll kind of pick up the pace here. 14 divided by 7 is 2. 4 minus 1 is 3. 5 minus 1 is 4. Then 28 divided by 7, 4. Subtract a squared. Subtract again, b to the first. Negative 35 divided by 7 is negative 5. Subtract is 0. Subtract again is 0. We don't need to write those. So in my final answer, I will not need this one.